Reuse. It's the entire reason Starship exists. And right now, SpaceX is towing a flown Starship across an ocean just to get its hands on it again. Meanwhile, the internet declares that the heat shield that brought it home can never work as intended. Today, we run the actual numbers on that claim. The results surprised even me. And then there is Flight 14. The signs point to something we have never seen before. A Starship that doesn't come home after an hour. One that might stay in orbit for days for the first time ever. And then it comes back for the catch. My name is Felix, welcome to What About It, let's dive right in. Starship updates. Let's start in the Indian Ocean, where the recovery of Ship 40 has moved from announcement to operation. 3 vessels are now on scene, working together to bring the floating Starship under control. Go Australis, the Normand Ranger, a Norwegian offshore support vessel, and a 3rd support ship. And thanks to the space engineer on X who has been tracking this operation hour by hour, we can put a precise timeline on the weekend. Early Saturday morning, between 2 and 3 a.m. UTC, a pilot tow line was attached to Ship 40's aft end, run over from the Normand Ranger. The vessels then held position for several hours before catching up with the drifting ship again, with the Ranger preparing the full towing rig. And as of Saturday afternoon, Ship 40 had been afloat for 184 hours since touchdown. Nearly 8 days in open water and still in towable shape. One question even the trackers can't answer yet, does Ship 40 travel nose first or tail first? Either way, the expectation going into Sunday was that the next daylight window would be the towing day. The plan is to pull the ship into a harbor in Australia. As we covered last episode, the legal path for this is open. The Technology Safeguard Agreement between the United States and Australia covers returning US space technology on Australian soil. SpaceX needs Australian permits, but nothing blocks the move. The real question is what happens after the harbor, because if SpaceX wants Ship 40 back home at starbase, the logistics get serious. A barge can't make that crossing. You'd need a proper heavy transport ship. The shortest route runs across the Pacific and through the Panama Canal, roughly 10,500 nautical miles. Depending on the vessel's speed, that is somewhere between 30 and 45 days at sea. A long trip for a rocket that was designed to come home in 40 minutes. So it might be that SpaceX doesn't attempt the crossing at all and investigates the vehicle in Australia instead. Teardowns don't care about the address. We'll have to see. But either way, engineers are about to put their hands on a flown version 3 Starship for the first time in history. Should SpaceX bring Ship 40 home across 10,500 nautical miles or investigate it in Australia? Let me know your thoughts below in the comments. And that brings us to the heat shield, because the closer you look at Ship 40, the more there is to learn. In SpaceX's images of the shield, you can see white streaks in certain spots running along the tile boundaries. Some people see those as damage. Here is what they actually are. Between those tiles sits a white mineral felt, a backup layer that protects the hull if hot gas finds a path between the tiles. During re-entry, some of that felt material streaked across the surrounding tiles. That is where the white marks come from. And here is the important part. There is no indication whatsoever that this reduced the protection the ship received. The hull came through clean, no burn-through. The shield did its job, and the streaks are the fingerprints of the backup layer doing exactly what backup layers do. Now let's talk about the discourse. Over the past days, my feed has been full of one theme. The heat shield will never work. Experts with decades of experience are still skeptical. And one line from a well-known spaceflight reporter stuck with me. It would be a dramatic failure if SpaceX needed to strip and replace the entire heat shield for 2 weeks after every single flight. You know what? Let's take that seriously. Let's assume the worst case is true. 2 weeks of shield work after every flight, does that kill high flight cadence? Let's run the numbers. But first, let's talk about a different kind of productivity. Let's talk about the most productive email app I've ever used. It's today's sponsor, Superhuman Mail, part of the Superhuman Productivity Suite. Email gets overwhelming fast, especially when half your time goes into searching, writing replies, and scheduling meetings. Superhuman Mail makes emailing manageable and easy, and here's what makes it different. With Write with Voice in the Superhuman Mail mobile app, you can speak your emails. This goes beyond simply transcribing your words. It interprets your intent and automatically refines your email.
Write an email to my electricity provider telling them that I am not happy with the rates.
The result sounds just like you. I remember how useless traditional voice-to-text tools felt. It was simply frustrating.
Calling Rajesh Kutrapali.
But Write with Voice changes everything. Then there's Ask AI. I used to waste hours digging through old threads to find one detail. Now I just ask and it pulls up exactly what I needed in seconds. And there is more to Ask AI. It can summarize and explain emails. That is especially helpful when digesting complicated technical information for the next episode. Start using a system that makes email feel less overwhelming. Get 1 month free with my link in the description today. Check it out now and help Y in return.
Back to SpaceX's numbers. What does high flight cadence look like? Let's formulate the initial goal. 1 Starship launch per day. Every day. So about double the amount of Falcon 9 launches SpaceX currently maintains. What would that take? Let's estimate. 5 launch pads, each able to support a launch every 5 days. A booster turnaround of 1 week, which, after what we've seen from Falcon 9 and the booster catches, is absolutely achievable. And ships get much more time in my estimate, a full 4 weeks of turnaround, precisely because of the heat shield. Here's what the fleet looks like. 10 boosters across those 5 pads, each flying 46 times before retirement. 30 ships, each flying 25 times. To sustain that fleet, the factory needs to deliver 8 new boosters per year and 3 new ships per month. For reference, Star Factory's goals are much higher than that. Shotwell and Musk repeatedly spoke of 1,000 or more ships per year. Run all of that, and the output is 365 launches per year, 1 per day. 36,525 tons of payload to orbit annually at 100 tons per flight. With 4 full weeks of turnaround time on the ships at a very low production rate. And now the detail that made me smile. I used a calculator by Ken Kirtland on X. Thank you, Ken. The calculator flags the system bottleneck in this scenario. It isn't the heat shield. It isn't ship production. It's launch pad turnaround. With a 4-week ship turnaround baked in, the thing limiting 1 launch per day is how fast you can reset a pad. So let's go back to the reporter's nightmare scenario. 2 full weeks of stripping and retiling the shield after every flight. Inside a 4-week turnaround, that still leaves 2 entire weeks for every other inspection and repair on the vehicle. The worst case the skeptics can paint fits inside the schedule with room to spare. And so how do I know that 2 weeks would be enough for an entire shield? Because SpaceX did it once. In June 2024, SpaceX completely stripped all the heat shield tiles from Ship 30. Roughly 18,000 tiles. They replaced the entire thermal protection system with a newer, stronger generation of tiles, plus a backup ablative layer underneath in key areas. It took them 12 days to remove all tiles, attach the back then new mineral felt, and be ready to install new tiles. This wasn't a refurbishment. It was a complete removal of the entire shield. I'm not dismissing the engineering challenge. Reusable heat shields are genuinely hard, and nobody has ever operated one at this scale. The shuttle needed months between flights, largely because of its thermal protection system. But the math shows something the discourse keeps missing. Starship doesn't need a shield that's perfect to achieve extraordinary milestones. It needs a shield that's serviceable in under 4 weeks. Those are wildly different requirements. And here's the payoff that puts the whole cadence discussion into perspective. Since 1957, since Sputnik, humanity has launched somewhere between 20,000 and 25,000 tons of payload into space. Every rocket ever flown. Every satellite, every station module, every crew capsule, every probe, 7 decades of spaceflight combined. 1 Starship launch per day moves 36,525 tons in a single calendar year. That is more than 1.5 times everything humanity has launched since the beginning of the space age. In 1 year, from 1 rocket family. That is what's actually at stake in the heat shield debate, not whether one vehicle needs new tiles. Whether the entire history of spaceflight becomes a rounding error.
Now to Flight 14, and on the surface it is quiet. Ship 41 has not rolled to Massey's for its static fire yet. We are watching closely and the rollout could come any day. But while the hardware sits, the mission's shape is forming and it is bigger than we thought. Flight 14 is expected to be the first orbital Starship flight pending regulatory approval. Not another suborbital hop. A real orbital mission which could last multiple hours or even days, with the ship potentially coming home up to 48 hours after launch. And at the end of it, the catch attempt. Connect that to the heat shield discussion we just had. Every Starship re-entry so far has been suborbital, carrying less energy than a return from orbit. Ship 40's shield passed the suborbital test with flying colors. Flight 14's shield may face the real exam. Orbital velocity, full re-entry energy, and then a tower catch at the end. The first catch attempt and the first orbital speed re-entry might be the same flight. One more note on Flight 14's mission profile. There are indications SpaceX may send Booster 21 to a controlled ocean splashdown instead of attempting a booster catch. The reason is straightforward. Booster 20's landing burn engine failures aren't fully understood yet, and stacking a booster catch on top of the first ship catch would compound the risk of an already unprecedented mission. The FAA approval for the expanded ship catch landing zone is also still in work, running in parallel with hardware preparation. This is what we can likely expect. Flight 14 goes orbital, the ship comes home to the chopsticks, and the booster takes one more careful swim. So is one launch per day realistic with a 4-week ship turnaround, or is the heat shield skepticism justified? Let me know in the comments. 3 quick items from Starbase. First, a brand new test machine. On Thursday night, a super heavy booster grid fin testing apparatus was moved from the production site to Massey's. This machine will let SpaceX test booster grid fins on the ground before they ever fly. Given that version 3 boosters fly with 3 grid fins instead of 4, each one larger and more heavily loaded than before, dedicated ground testing for these parts makes a lot of sense. Second, S39.1 is back at the production site and receiving upgrades for future test campaigns. Crews are currently accessing the inside of the tank through manholes. The test article that already survived 15 cryo campaigns is being prepared for more. SpaceX keeps squeezing knowledge out of hardware that never flies. And third, our old friend, the mystery nose cone, has a name. It is now called S43.1. On Friday, the structural test nose cone and payload section with a Starlink dispenser installed inside was lifted onto a forward dome section for assembly in Megabay 2. Once complete, it heads to Massey's for testing. Put S43.1 next to the S39.1 work and a pattern emerges. SpaceX is deeply interested in payload-based structural integrity right now. And after Flight 13 deliberately flew the highest dynamic pressure ascent ever, specifically to carry more payload per flight, that's exactly the part of the vehicle you'd expect them to be stress testing on the ground. So here's where we stand. A Starship is under tow in the Indian Ocean, heading for an Australian harbor and a date with the engineers. The heat shield debate rages on, but the math says the skeptics' worst case still closes. Flight 14 is shaping up to be orbital with the first ship catch at the end of it, and at Starbase, the test hardware tells us SpaceX is already engineering for heavier payloads. The quiet weeks are never actually quiet. Ship 41's rollout could come any day now, and when it does, the countdown to the catch begins. We need a larger station for our hype trains. Yay, you've reached the middle of the video. You made it. Thank you from the bottom of my heart for watching and liking the video. If you're among the 40% who haven't subscribed yet, and there was at least one video you learned something new from, it would mean the world to me if you did. It is free, and it genuinely helps more people find my channel. Want to make my world even easier? There is only one place you'd rather be. The Y Members Club on Patreon and right here on YouTube. Click the card or the join button under the video. You are the reason we keep doing this. Thank you so much. You rock. Next, let's talk Moon. Let's talk Artemis. The vehicle assembly building, still one of the biggest buildings on the planet. It was purpose-built to allow the indoor integration of a monster rocket, Saturn V. The one that took humans to the moon for the first time in history. Today, the VAB is again playing its part in the return to our neighbor in the sky. Inside it, the third SLS rocket is being stacked piece by piece. It's coming together faster than a lot of people expected, a sign of just how much NASA has changed since Jared Isaacman took over as administrator. And the SLS being assembled right now is the one for Artemis 3, the last Artemis mission that will not go for a moon landing. We've talked about the mission details before. Now it is time to have a look at the practical stuff. What's already built? What's the crew doing? What still has to come together before SLS can once again leave the pad next year? Let's start with the spine. Back in April, the core stage got barged into Kennedy. That's the most visible part of the Space Launch System. The iconic orange section, a visual reminder of the Space Shuttle days. A 65-meter tall giant, big enough to match a 20-story building. To start the integration process, the mobile launcher had to be brought back into the building after initial inspection and assessment of the required refurbishment. All 4 of the rocket's main engines have been delivered. These are RS-25's previously flown engines from the Space Shuttle program. The 4 specific engines assigned to Artemis 3 are the serial numbers E2048, E2052, E2054, and E2057. Combined, they supported 36 space shuttle flights. L3 Harris, who acquired Aerojet Rocketdyne, the original RS-25 manufacturer, did the refurbishment and upgrade to these engines. Upgrades include modern electronic controls, improved thermal insulation, and a higher thrust capability than they utilized during the shuttle era. In a sense, the shuttle era ultimately ends with Artemis 4, because that's when the last batch of old engines is planned to be used. After that mission, new ones will have to be used if NASA wants to fly more SLS rockets after Artemis 4. Isn't that a poetic final encore for the Space Shuttle program? It ends with a start, the first time humans attempt to establish a permanent outpost on another celestial body. NASA has long since signed contracts for newly produced engines with L3 Harris. The initial batch has 6 engines, and a subsequent order calls for 18 more. The first newly manufactured RS-25E engine was completed in 2024. Now to the twin solid rocket boosters. Those are the tall white pillar-like rockets that are strapped onto either side of the core. They started going up inside the VAB in July. That is the first hardware that is physically stacked onto the launch platform. And over at NASA's Marshall Center, they just finished welding together a special spacer. This spacer is a structural filler piece that sits in the stack where a moon-bound mission's kick stage would normally go. But because this flight will stay in a low Earth orbit, this SLS doesn't need the kick stage. Engineers needed to come up with a solution. Simply leaving it out is not an option. It would be a massive change to the launch vehicle's behavior, almost like having a whole new rocket to work with. The solution is pragmatic. Build a placeholder to match the piece it replaces. Simple and effective. Obviously, the rocket is only half the mission, so it is time to have a look at what and how the crew is doing. The 4 flyers, Reddy Brezhnik, Luca Parmitano, Frank Rubio, and Andre Douglas, started training in Orion systems in June. These trainings are performed at NASA's Johnson Space Center in Houston, Texas. And on the day these 4 were named, the time started ticking. NASA gave them roughly a year to get flight ready, which tells you a lot about how tight this timeline actually is. Tight, but not reckless. Just to become a part of the astronaut program, they had to prove themselves, and they have been training ever since. Space quiz. What else do you need for a future moon mission? Vehicles, astronauts, and? The answer is spacesuits. Even though Artemis 3 will not be putting people on the moon yet, the astronauts on this mission will bring one of the newly designed spacesuits with them. One of the crew members will do a hands-on hardware check inside one of the landers in the AX EMU. This next-gen spacesuit by Axiom Space has been going through pressure and mobility testing at Johnson. Here, astronauts run simulated tasks at different suit pressures to see how well they can actually move around and work in them. The Artemis 3 crew was also spotted visiting Kennedy Space Center. They walked the processing facility to see their flight hardware coming together. All in all, it looks like on NASA's side, the to-do list is pretty clean. Finish integrating the core stage, getting the engines mounted, and then lifted into place between the boosters. Then the spacer can be stacked on top of the core, followed by the Orion spacecraft. In the meantime, they keep running countdown rehearsals. Full fueling and terminal count simulations have been performed every month since spring, all to keep the teams sharp and ready for that next launch. NASA's own phrase for its mood is full steam ahead. The real risk for a significant holdup is neither NASA's SLS rocket nor its personnel. This whole mission exists to test things before going all in on the moon landing. And to land on the moon, you'll need a moon lander. Test docking is the single most important component of Artemis 3. Twice, in fact. NASA wants to perform these maneuvers with both Artemis landers, SpaceX's Human Landing System, or HLS, and Blue Moon by Blue Origin. Without these landers, the mission won't fly. By now, it's clear that a fully featured HLS will not be ready in time. Fortunately, it does not need to be. The mission requirement only calls for the docking test, and for that, SpaceX will provide a modified Starship. Blue Origin also has no reason to have a fully functional lander ready for this mission. Systems vital to the moon landings, like the propulsion system, are not needed for the docking test. The lander mock-up will end up burning up in the atmosphere, so why waste valuable hardware? There is one requirement, though, that both lander mock-ups need to meet. The test articles have to be certified safe enough for the crew to go near them, and this will also take time. So the SLS could end up stacked and ready to go, but has to wait for the rest of the Artemis 3 hardware. Who would have thought? Good timing to talk about the date. The target is no earlier than late 2027. Is that solid? Not everyone's sold, and I have to admit that I am not sure about that either. Even government auditors already flagged the Artemis 3 schedule as risky. NASA has pushed back that this review didn't fully account for the important changes that have been made to the program in the last months. While this is a valid argument, it can't fully brush away the concerns. With external private entities contracted to provide essential services to the Artemis program, some elements are simply not under direct NASA control, and there's only so much the agency can do to help the contractors meet their goals. Going back to the moon is not just another mission. Yes, humanity has become really good at getting astronauts to low Earth orbit and back. There are even multiple options, with China and Russia having their own human-rated flight hardware in regular service. Going back to the moon is on a whole different scale. The Artemis program is the biggest and most complex space project since Apollo. Nothing comes even close. Success will have to rely on meticulous engineering and thorough testing. If Artemis 3 slips to 2028 and the first Artemis moon landing happens even later than that, I'm fine with it. But if anything goes wrong, humans will be in danger. No one is fine with that. Humans will set foot on the moon's surface again soon. If the schedule has to be adjusted, it is just part of space exploration. So, what do you think? Will Artemis 3 actually fly in 2027, or does it slip? Can NASA astronauts walk on the moon in 2028? Let me know down below. And that's it for today. Smash the like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. Our all-time favorite Raptor engine design and countless others are there for you to explore. Click the card or the US or worldwide link in the description. History is being written in real time. If you want to catch the other historic stories from recent weeks, click the video on screen and continue the journey now. Thank you for watching, and I'll see you again in the next episode.